Okay, vehicles free to crane, you can start driving. Okay, Herc, free to you guys are good.
Bob, the res is really high. The res in your bubble. It was up to max.
It's up to what?
The, well, I can't even see the numbers that high, right?
Yeah.
It was up to
It's okay.
35?
Yeah, I just pushed the...
Okay, roger.
It's just got to cool down a bit.
Okay.
It's about the best shot of the bottom of the boat we've had so far.
Okay, August is going down.
Nav bridge.
Go ahead.
Yep, the vessel is back in DP, now position holding.
Copy, thank you.
This is an audio slate for dive Hotel 1860. UTC time is 151138. Mark. You guys ready for your dive, Salvo?
Sure. Thank you.
Ethernet bulb's on, but that spare power's not.
Spare power is on. Yeah, so what do I do? Let mom like this one? Okay. Yeah. So mon left is Norb, right? Mon left. Raj, okay. And then while center, or
9K ground.
oh,
Dan,
Dan.
9K ground. Dan,
Stop 50, you guys ready for control?
ready.
Dan, can you hear Bob?
Ready.
Okay, Roger.
Van is ready for control.
Okay, go ahead and bump it.
Okay, bumping. Hold on.
Hey, Van, you've got it. Deck's going off comms.
Roger.
Copy. Thanks, Mark.
And Captain
Yeah,
going off
doing your
comms.
thing. Thing is killed.
It was worth a try. It's a good idea to have a gauge camera. Oh. Yeah. I mean, it probably is. I said it probably is. It was, yeah.
Yeah, there is a big change, so I think it's gonna. Yeah, that was it. Nice try.
He's got 12 hours to figure out a new workaround.
I don't know.
Hey, Nev, I'm missing my
Oh, good.
positional information on the closed captioning. Does it come from you?
That the vehicle positions?
Yeah,
Yeah, we had a little bit of trouble getting the USBL started. You should be getting it now.
stand by. Okay.
Bob, on ONC, what would be the most useful nav screen to have up? What do you think? This one or
Yeah, I mean that's all you're gonna. Yeah,
Roger?
that one. Yeah, this one. They don't have any underlays, and they don't even put any targets on. It's pretty useless.
Well, it's good to know where the vehicles are.
Yeah, but it's no good for knowing where the targets are,
Right.
where you're trying to go. Yeah, trying to get to.
Good morning, everyone.
Your sequence is off. Can I turn it on?
Good morning.
Megan, was that you?
Yep, I'm here in Studio 1. Can you
Studio
hear me?
1, great, thank you. We're going to hear you a lot better in just a second.
Perfect.
There we go. How are you this morning?
I am great. How are you?
Good, doing very well. Nice day to go boating.
Let's go on a seafloor adventure.
Yeah. Sounds like the beginning of a kid show.
It did.
It does.
Like the guy, the teacher from Finding Nemo. It's like, let's go on an
yeah.
adventure.
Yeah, yeah. Thank goodness.
Yeah. 20-meter range on the top. I think later I'll pull up the CPRNs and the mezzo like manuals, so I can understand the settings instead of just guessing. So, I wrote it down. When we found it that we liked it, it was the sensitivity was low, the dynamic range was mid, and then you would just set the gain accordingly, but it wasn't that high. So it was like, you know, does it, or can you just change your range? Yeah, but wouldn't that just be gain that you would just reduce? Noise, right? Yeah. And then like middle dynamic range. Okay. Well, there's some noise. Do you see it? Do you want me to play around with it? Roger. Got it. I got it. Okay.
Taylor, you want to walk us through the dive plan, what we're doing today?
Sure. So we're going to be exploring a plume
So I decreased the sensitivity.
that we saw
And I'm
at
just,
around,
I'll figure out what.
1,600 meters depth. Yeah. And we're going to try to find some bubble streams. So similar plan to what we had yesterday, where we're trying to find these bubble streams and potentially find hydrate.
Single-digit sensitivity.
To sample from. There's going to be a really big crater at the
And
bottom.
the gain is only 33.
That we're also going to explore the width of. See
Okay,
what we find
and
there.
the gain is
and make like a high
way down. It's
resolution
like a quarter, a third of what it was.
image of that crater. So hopefully we can find some hydrate
Let's
today
find
at
out.
this methane seep.
Yeah, hopefully so. We tried so hard yesterday.
Yeah. Hopefully today's the day.
I know. That's why I want to see, like, I want to see a great change, right? So I'll like kick it up, and then it'll be like, and it'll be like what it was, and then it'll be what it is, and we'll be able to tell what it did.
Sounds like you're having a poetry slam over there.
Especially because we can only hear half
what
of
it is,
on
or what it was, or what it is,
What it's
or what
gonna
it
be.
is, or what it's going to be. What it is, or what it is.
And I want a big change. Yeah.
Sumaziga.
Great.
It didn't do anything.
Huh.
Like, it's just fuzzier, like, versus this being like a little bit cleaner versus that.
Yeah. All right.
It's
But I think it's good because we can see those
lines.
the noise there.
Yeah.
Yeah.
Oh, I'm sorry. I think it's a little clearer. It was like this,
Ah.
and it got blacker in the background versus cloudier.
So this shows up
More-
better relatively.
Yeah. Yeah.
I think that's good.
Okay.
So I assume there's going to be more rocks here too, right? Since we're on a little mound. I don't know.
That'd be cool.
What's the kind of slope on the thing?
Chris, are you giving an excellent explanation right now? I can see the screen moving, but I can't
No.
hear you.
Quiet as a church mouse over there.
Good morning, good afternoon, good evening. Anyone tuned in, watching us, we're happy to have you with us. We're descending to 1,600 meters today for this dive. Brand new exploration. The site was identified by the multi-beam. We'll head down and put the first human eyeballs onto the site and bring you along with us as we go. If you have questions for the team, drop them into the chat on the website. Happy to bring them into the conversation. There's our little McTovid escort. Do you all have an introduction question you want this morning?
How about the name of the high school you graduated from?
Perfect. All right. Your name, what you do in the van, maybe what degrees or certifications, do you have? And then the name of your high school.
And can you include your high school mascot?
Absolutely, we can.
Yeah, that's cooler. Okay,
See,
cool.
there you go. Thank you.
You got
Some color. No, I don't. But it's.
okay.
I want to compare mine to others.
Okay.
I want to see
Okay,
where
perfect.
if they're all lame.
All right, Kelly, kick us off.
Oh boy. Okay, I'm Kylie Pasternak. I'm Argus pilot. I have a engineering associate's degree. And my high school was Durfee, BMC Durfee High School, home of the Hilltoppers.
Ooh. Is Durfee the name of the town?
No.
Okay.
No.
Dorky?
Durfee. Durfee. It's BMC Bradford Marshall Shaloner Durfee High School in Fall
Just
River.
rolls right off the tongue,
Doesn't
doesn't
it? Home of the Hilltoppers.
Who's up?
You.
Yeah.
Me?
Go ahead.
I'm Robert Bob Waters, and sitting in the Herc seat. And I went to Coronado High School in California.
Nice.
They were what the heck were they? It's been a couple of years.
Yeah. You don't have the old jacket in your closet anymore?
No.
Hey, I'm Chris Krasnowski. I have an undergraduate degree in physics from Ohio Wesleyan University, master's degree in mechanical engineering from Drexel University, and a PhD in oceanography from University of Rhode Island. I went to Bloom Carroll High School in Carroll, Ohio, and their mascots are the Bulldogs.
Somehow I didn't know you had gone to Drexel.
Did you not?
No.
But everybody knows Drexel.
Oh.
And it seems like everybody has some random link.
Yeah.
Yeah.
All right. Good to know. My name is Ed McNichol. I'm the lead video engineer on board, so I'm shading all the cameras, making sure we're recording, making sure you can hear what I'm saying, which is a very important thing to me, and responsible for all of our deliverables. I actually got my training in the military, went to film school in the Army, and then transitioned into television and video production as that came out. And I'm rocking a high school diploma from the Archbishop John Carroll High School for Boys, just outside of Philadelphia.
Was there a mascot?
Oh, yeah.
Boys. The mascot
Yeah,
is boys.
yeah, no, it's actually no longer a boys-only school, as it happened to many of those schools. The Patriots.
The Patriots.
I'm not quite sure why, but Patriots. Like we have a strong, well, I don't know, maybe it's the colonial history there. So, and you, Taylor Ann?
Oh, yeah. So I'm Taylor Ann. I'm the data logger and science manager in training. So I'm the one taking notes as we're diving and also processing samples in the wet lab and typing up reports. I have an undergraduate degree in just general biology, and I'm currently getting my master's in marine science at Cal State Northridge. And I went to Beecher High School in a very small town. And our mascot was the Bobcats, nothing cool, but
Bobcats are awesome.
Yeah.
I feel like everyone's mascot is a bobcat or a wildcat.
What was the small town?
Beecher, Illinois.
Oh.
Yeah.
Is that near Rockford? Is that in a Chicago suburb?
Yeah, it's a suburb, very
Yeah.
far south, almost Indiana, near like
Yeah.
Kankakee-ish area.
Awesome. I'm Megan Cook. I'm the communications lead aboard this expedition and sitting the communications seat here in the van during many of the watches. I have a undergraduate degree in biology and a minor in chemistry and an option in marine biology from Oregon State University, go Beavs. And I am a graduate of Centennial High School in Boise, Idaho. And I'm doing a master's right now. I forgot that part. Working on a master's in environmental management and leadership right now, and went to Centennial High School in Boise, Idaho, home of the Patriots. Double up, Ed.
Yeah. You know, the reason I chose that question is because I was on a vessel once and found out one of the mappers had also gone to my high school.
That's
Found
awesome.
that out like halfway through the mission. Not the same year. I think he was 20, 25 years after me.
I was going to say, did you take a picture and send it to their like alumni
No, I
newsletter?
have not.
I'm super excited. I'm going to, the people who are here from Oregon State University, I don't know if they're as excited as I am. I'm like, we're going to take an Oregon State University photo.
Oh, hold on. We have one more person in the van with us. Look at that. Tim Burbank's back here.
Damn it, I was trying to lurk in a corner checking data streams.
You're hiding.
I have a mirror here.
I can't see you from the studio.
Ah, yes, the video seat rear view mirror. But yes, hi, I'm Tim Burbank. I'm a data logger. I don't belong on this watch, but hopped in to make sure we're recording things we're expected to be recording. I have, let's see, a degree in film and a degree in computer science from the University of Rhode Island, and a high school degree from Amherst Regional High School with a mascot of the Hurricanes, because that seems cool to inland people.
Oh, no.
That's great. Thanks, Tim.
Oh, I remember the
Oh, you did?
mascot
What
now.
is it?
The Islanders.
Ah. Because of Coronado?
Yeah,
Huh,
it's an
yeah.
island.
Yeah.
Not really an island, it's a isthmus.
Yeah.
Can you educate us on the difference between an island and a
It's actually connected by a very thin, what they call
like a
the silver.
causeway?
It's called the Silver Strand.
Oh,
Yeah,
okay.
it goes all the way down San Diego Bay. Yeah.
Yeah.
Okay, so it's mostly an island,
Very
but it's just
narrow,
like one
yeah.
way on, one
It,
way off.
At one point, it's like only like 50 yards across.
Oh, wow.
Yeah.
Exclusive.
Yeah. I could not afford to live there.
All right, Bob, question for you. Folks want to know, what instruments do the ROVs have that are going to help us find these seeps and plumes?
I think Chris could probably weigh in on that better than me.
Well, we have a bunch of sonars basically for doing that. So we start by mapping the area with the ship's multi-beam sonar, which gives us an idea of where the plumes are, sort of a general location. Okay.
Hey.
Anyway, okay, so after we map the area with the ship's multi-beam, we have a couple sonars on Hercules and Argus. We have several scanning sonars on the vehicles, which just do basically a sweeping pattern looking out ahead, and those can see the methane bubbles they're pretty easily at range. And we also have a multi-beam sonar on Hercules, which we can either point down or forward. If it's in the forward configuration, we can use it to find bubbles. Today it's in the down configuration, and we're going to use it to do a little mapping.
I know we have multiple scanning sonars on Herc. Why so many?
That's maybe a question for Bob, because I don't exactly know.
Well, so the Sea King sonar is hanging under the, I can point at it here. So over here, if you look at the Herc view, this thing with the blue cap on it, that's the Sea King sonar. And that's kind of the pilot's kind of aid to navigation there. We use it up close to kind of find our way in the over terrain. Gives us a good close-in picture. And then up on top of Herc is a mesotech sonar that's typically set to a longer range. And that's for obstacle avoidance kind of things and looking for overall slope. There's another mesotech sonar that's on Argus, on the bottom of Argus. And that's used for finding terrain features that are more of a range and to keep Argus from bumping into the slope. And then the Norbit, which is not used all the time, which is the multi-beam one that Chris was talking about.
Gotcha.
Is there any tool you would like to have that you don't, if you were imagining new capabilities to help you find bubbles or just in general other features on the seafloor?
Hi folks, I'm Susan Murley. I'm the watch lead for for this 8 to 12 shift, and I work for Oregon State University with Pacific Marine Environmental Lab NOAA Earth-Ocean Interactions Program. Today we're going to be diving about 50 miles west of Tillamook, Oregon, in a very deep site. It's in 1,600 meters of water. That's about over 5,000 feet. It's on the mid-slope. At the base of the slope here where the subduction zone is, it's about 2,500 meters. So this is one of our deeper sites that we're going to be diving on. So it's going to take us over an hour to get to the bottom. When we get there, we plan on taking all of our seafloor samples. We're hoping to see a bubble stream down here, a methane bubble stream, and sample that and sample all the some of the bacterial mats and take some push cores, sample the sediments, take some samples in the water column with our Niskin bottles. We're going to be diving on what appears to be a ring crater feature. It's about 375 meters in a diameter with a depth of about 20 meters in the center of it. It looks like a donut on the seafloor. So we're looking forward to looking at the morphology and finding out why this strange donut-shaped feature is on the seafloor here. So looking forward to it. It'll be about another hour until we get to the bottom.
So Susan, our intro question was, what high school did you graduate from and what was their mascot?
Where did I graduate?
Yep, from high school.
I graduated from high school in Barron, Wisconsin. And then I went on and got a degree in oceanography at University of Washington with an emphasis in marine geology and geophysics. I now work for Oregon State University. I also went on and got a graduate certificate in GIS, Geographic Information Science. So it's basically a way for us to take all of this information that we gather out here and to map it, put it on maps, and be able to interactively work with those data. So, and I did that about 7 years ago, so it's never too late. I didn't get my college degree until I was 33, and I got that graduate certificate when I was in my late 40s. So it took me a while to decide what I wanted to do when I grew up. I traveled a lot when I was younger.
And what instrument would you want on the ROVs to help you find the methane seeps? Susan? She's not listening.
Did you hear that, Susan?
I can hear you.
I did not hear you.
Can you hear me?
Sort of.
Let me check your levels real quick.
Okay,
Over
yeah, I'm feeling a little bit deaf these days. I think it's time for hearing aid.
I can help with that.
Can you repeat that, Bob? Did you ask a question?
Well, there was a science question that was asking if you could, what instrument would you add to the ROVs to help you find the seeps?
Well, I got to say that the instruments that we've added have really helped. This lovely sonar that looks into the water column has been amazing. I don't know. You guys are engineers. You tell me what we need to add.
Well, is there chemical sensors that maybe would help you?
Probably, because the chemistry of these seeps is different than the surrounding seawater. Chemical sensors would help. For me, I'm a visual person, so, you know, just some way to visualize them even better than we are able to right now would be helpful. I'd like to see it look like it looks on the multi-beam data, you know, like this honking flare, but once we get down here, it's a little bit different. It's sort of deceptive. My specialty is seafloor and water column mapping. And when we look at the data in the water column data that we collect from the ship, These things look like they're big, huge flares, but that really has to do with the acoustic difference between the methane and the surrounding water column. So these bubble streams have a different acoustic impedance, and it'd be nice if we had something like that, you know, like we see when we look at the multi-beam water column data.
So the Norbit sonar is mounted in a down-facing configuration, right? This dive?
Today it is, yep.
Yeah, so that's, to me, I think that works really well to find bubbles. If you fly up high over them, and you see the hard return from the bottom, and then the bubbles show up in the sonars, you know, coming at you, so that, you know, you see it.
Yeah.
The range decreasing as they come at you, which is more like the ship, right?
Right, and yeah, this will be different to look at today.
How wide is the view, Chris, on the Norbit when you do something like that? Like what angle does it look out at?
How wide do you want it to be?
Oh.
Yeah. It depends on how high you fly, right?
Well, yeah, or if the Norbit will do angles all the way up to 220 degrees or something. So, I mean, but that's, if you're doing downward looking, that obviously doesn't do you a whole lot of good. A typical survey swath is maybe 160 degrees. But if we're forward looking, you can put it as, we usually put it to 180 degrees. So you can see anywhere in front of or to the side of you.
And a typical multi-beam sonar system has about, well, I like to run it at about 120 degrees.
Yeah.
So we see 60 degrees on each side.
Yeah. So Susan, this point that you gave me is at the other site.
It is. It's like after we're done with looking at the crater, Jeff will be doing a little bit of geological poking around to the north. So it doesn't have anything to do with this crater that we're going to be looking at.
Okay.
And it's a possibility we won't even get there because we're spending so much time going up and down in the water column.
Okay.
It'll be the last point.
Well, all right. It's like an overnight transit away with the ship. Like, I don't understand. I'm not understanding.
It must be the wrong latitude or longitude.
Well, no, I checked it. The point was already in there, actually. This 2019 hydrate point. It's up at his, yeah.
That's not it.
Okay.
I'll be back.
Regroup on that point. All right, Taylor Ann, here's a question for you or anyone in the van. But I'm going to say it's for you. Could someone explain oxygen saturation and why it matters? And when we say like higher and lower, what kind of numbers are we talking about?
Yeah, so we're talking about, I guess, how much water or oxygen is in the water that we're in. So an example of really low oxygen saturation would be near zero, so very anoxic or the absence of oxygen. And an example of knowing when you're in an area like this, the sediment will be kind of black, really dark in color. Not many things living in it that we can see with the naked eye, but sometimes there will be. And then if there's a really high oxygen saturation, you'll tend to see more living things in that area that can, use the oxygen in the water column to survive.
Does really high oxygen concentration mean like 100, or does it mean some other number?
I'm not too sure. I think it depends on what the saturation's reading at in terms of percent or micromoles per liter.
That seems to be a more common unit for oxygen measurement now, is micromoles per liter.
Yeah.
ROV, is the stealth camera powered on right now? Suspicious. It's not talking to us. Try that, and then I'll ask more aggressively.
Oh, it says it's off.
What kind of animals can survive really low oxygen saturation? Have to see a bit of that. The last expedition in Santa Barbara Basin. Certainly microbes of different kinds, foraminifera for sure. But we did see some other animals, you know, in low oxygen conditions, you know, that they may be able to go into the area and then leave again. You know, they're just not going to stay there. You know, it's energetically taxing to be in an area where you can't respire very easily.
Yeah, and it can depend on like the stage, the life stage of the organism too. It'll vary. But yeah, anything super extreme. So,
but like larvae can do better or worse, and you see it vary by life stage.
I think it depends on the organism. Yeah. Is the stills camera working now, Tim?
Still haven't heard from it.
Okay.
You say that so casually, like it's like a friend you're waiting for a text from. Like, haven't heard from them. I don't know. Maybe they stopped for a coffee.
Still waking up.
Nah, it just woke up. We'll give it some time.
Hey, Bob. Getting some still shots over here. Can I have you toggle starboard and buck and port and bio?
I got it.
Oh, she all over it.
Hey, front row, folks want to know, could any infrared technology work underwater to help find targets? What are your thoughts? Oh, I can't hear you, Bob. You're off SPL. Come back.
Yeah, I don't think so.
Okay.
Yeah, I think, yeah, the water absorbs the light too quickly.
On the red scale.
Yeah.
Right.
Yeah. So you can like see that extreme around the hydrothermal vents where the water's coming out at, 350 degrees Celsius. And you go 2 inches away from it and it's back to ambient seawater.
Kylie, thanks for that. You can put those cameras back.
No problem.
Or
Thank you.
configure as you desire.
Sure.
Oh, it's always an interesting part of talking about hydrothermal vents. we talk about the like boiling, roiling water, and we can fly around them. You just can't stick the tether right over one, or
yeah, the water's hot enough to melt lead, so yeah, it's. You can see that the tube worms that live really close to the vents, like the what are the worms? The alvanellids that live right like half an inch from the mouth of the vents. So one part of their bodies and like near boiling temperatures, and the rear of it's in freezing water.
hard way to make a living.
Yeah. They seem to enjoy it though, right?
Viewer wants to know, what is the likelihood we see a 6-gill shark down here? Great question.
Wow.
Don't have a great answer. Possible.
So from my experience, they like to hang out at the bottom of cliff faces, rocky walls. You always find them near the bottom of those.
Do you have a favorite encounter with one?
With those? I don't know about favorite encounter. I don't know. It seems like they ignore us pretty much,
The Seattle Aquarium had a really strong 6-gill monitoring program because they had 6 gills that would gather under their piers there.
Oh.
And then they just, out of the blue, all disappeared and stopped coming by. And I don't think they've returned. But that's very shallow, of course.
Interesting. It'd be so interesting to know what, I don't know that we'd ever say caused it, but what was, maybe causal and happening at the same time.
Yeah.
When I was working and living down in South Africa, the white sharks would disappear when the transient orcas would come in to False Bay. And so the white sharks would just take off and you wouldn't see them for a few days as like a bigger predator came to town. And, that is very causal, but that is the repeated observation of lots of naturalists on the water and scientists for a long time. And it makes sense. They're a prey item of this larger predator that would, just every few months come through the region and make themselves scarce. Okay, Ed, what do you like most about working on a ship?
I enjoy the fact that every day is different. You never know what is just outside of our lights that we're about to see. I like that it's challenging. I can't just order a new part or a new something on Amazon and have it tomorrow. I have to work with the resources I have at hand, so I have to manage the system so I can overcome any challenges that presents. I love the fact that I get to mentor young professionals and help them out in the early stages of their career. And I like to joke, I think I was telling Tim the other day that I have 39 years experience, and there's some days at sea where clearly I needed 40.
Are you passing the question around?
Absolutely.
Yeah, jump on it.
My favorite part about working on a ship, it's really hard because I feel like I have so many favorites. I really love when I'm processing samples and I'm like, getting sleepy, and then all of a sudden I look up and I either see the sun rising or like yesterday, we saw some whales, some flukes, and that was really incredible. So all the things that you can see, just being surrounded by the magic of the ocean. But I also really love the hard work. Like, I love the quick pace of the work out here. It keeps me busy and always learning something new. Yeah, and then I guess my third favorite thing is being rocked to sleep at night by the ship. It's very soothing, very relaxing, and hard work out here. It's a weird mixture, but it goes well together.
How long were you processing samples last night?
I think I went to bed around 12:30-ish. No, actually I think it was a little earlier last night, maybe 11. Yeah, we came up a little bit early, so maybe cut an hour off of processing time, but we were processing samples from on deck time around, I think maybe we got around to samples at 7-ish and then finished at like 10:30 or 11.
Was Anson still up? He was describing how many hours his samples would take.
Oh yeah.
Today.
Yeah, I think they were still in the lab for quite a while. I'm not too sure though. I feel like that they usually are in the lab a lot longer than we are with the samples. But we got all of the bio and water and sediment settled.
Well, Susan here, I guess my favorite part about being at sea is Taylor Ann stole everything I was going to say. Basically, it's the sunrises and the sunsets. I saw the most amazing moonrise a couple of days ago with that full moon. It looked like a sunrise. The moon was so big and bright and orange. I don't know if that has to do with fires, but it was just amazing. And the sunsets and just the interactions with all of the people and probably, working with the remotely operated vehicles. And it seems like we rarely go on a dive where we don't find something new.